Good afternoon. My name is Carlos Escapa.
And I'm Jorge Lopez.
And collectively, we will be your data hombres today.
For 1 hour.
Exactly. So data is a key corporate asset. It is an adage. It is used openly, commonly, to refer to data, but very few companies actually treat it as an asset in the same way that an airline may treat airplanes or a retailer may treat warehouses. And yet the data are being used to drive very significant corporate value. If you look at the rise of the capitalization of companies in the last 20 years, you will actually find that intangibles, of which data is probably the most critical, have driven the most valuation in companies. Today we're going to be discussing why that is happening, and we're going to give you some ideas about how to drive value in your organizations and in your customers' organizations with decisions that are supported with data.
Thank you, Carlos. So I was just making sure that it's the correct deck, which seems to be. So I think we can all agree that organizations need data, not just to lead, but even to remain competitive in the market space. So to place some numbers into the argument, Aberdeen Research did a study last year. And they found that organizations that can successfully manage their data and get value from it are outperforming their peers in organic growth by up to 9%. So it's not insignificant. And these are organizations that are using data in not just the traditional way, but they are actually building sophisticated analytics, including real-time and machine learning, in order to get better business opportunities, to identify areas for cost reductions, more efficiencies, and better engagement with their customers. But if we take a step back and look at where we were before, traditional analytics used to look like this. You had a number of different sources, most of them internal in the company. So then you will have an Etl process to extract, transform the data, and load it into your data warehouse according to a predefined schema. And then you will have some canned reports, traditional business intelligence. And this model worked well for some time. But after a while, organizations started to realize it had some limitations. First of all, it was optimized for relational data sources. It's like a table format. It is difficult to scale, usually just terabytes of data, if some of them may be petabytes of data. One of the key limitations, it had a rigid schema design. So it required the users to first think about all the questions that they could ask from their data. And then based on that, they will define your typical data model or business model. And then based on that, you basically design your entire data warehouse. So what that means is if you have more questions later on, it takes a whole lot of time to get them answered. And the reality is that the mind doesn't work that way. The more you ask questions and you get answers, new questions that you didn't even think before arise. So that kind of hindered a little bit of the analysis and the capabilities. And last but not least, of course, they incur very, very large, they require a very large investment in capital expenditures and as well as operating costs. So in addition, there are a few forces, and I think most of the room might be familiar with those in terms of what we used to call big data. So what happens is suddenly organizations need to capture a lot more data, not just relational sources, but data from different sources, such as social media, mobile devices, IoT sensors, logs, and all that comes in different formats, from audio files, text files, emails, images, videos, etc. All this information is also coming a lot faster. So they need to analyze the data much faster and react to that much faster. One typical example that we have on real-time analytics is in order to make the decision whether of placing an ad or not on a given web page, they need to look at dozens of variables to determine if that is the right target audience. And then they need to kind of customize the ad for you to display on the page. And all of that has to happen within milliseconds or less, because otherwise people don't like to wait forever for the pages to render, right? So all of this started to create pressure. Data growing at a very accelerated pace. For instance, data coming from machines, generated by machines, is growing at 10x faster than the rest of the data. And it's practically impossible for organizations just to add capacity to manage all of that, constantly add capacity to manage all of that. So at some point, organizations realize that their implementations, their traditional architectures are no longer effective. They are not sustainable. So they look for ways to modernize their architecture. And usually what we find is they look for a modern kind of a data warehouse in the cloud. So they start looking at options. They land on their data warehouse on the cloud. And one of the first steps is maybe they move their data into sort of a staging area. Commonly, we see customers using Amazon S3 as very scalable object storage. They move all their data to Amazon S3. They stage it there before they do the required transformations and then load it into the cloud data warehouse. And then they start operating with their kind of modern data warehouse. And this is all good. But at some point, they realize, OK, I already have a lot of data on S3. And I have all these users that are asking me to access more data, different data sets, and to slice it and slice and dice the data in different ways. So some users are granted access directly to that data. They may run queries with Athena, other queries just running SQL. They may use Amazon EMR to run some algorithms or develop some applications. And guess what? At that point, that architecture starts to look a lot like a data lake. So, no? OK. Let me try with this. So what is a data lake? A data lake is, the way we view a data lake at AWS is more of an architectural approach that enables you to store massive amounts of data into a central repository so that different groups within the organization are able to categorize it, process it, analyze it, and consume it in different ways. And this is exactly the type of architecture that can help a lot of organizations, a lot of our customers to utilize data as an asset. It's kind of a stepping stone or lays a very solid foundation so that they can then get more value out of their data. So what are some of the benefits of this architecture? Well, a data lake allows the customers to store virtually any type of data, all the sources that we talk about, unstructured, semi-structured, and structured data. They can run a lot of analytics on top of that data, in most of the times without even moving the data. So instead of maintaining different copies of the data, they can just run different clusters and different applications against this data without moving it. Again, they can throw analytics such as Amazon Athena, Amazon EMR, etc. One of the key differences with this architecture is that it decouples storage from compute. And this is a massive shift from the architectures from the past. This enables a lot of agility for the organizations, because now they can just focus on the resources that they need. If they need more storage, they scale the storage. If they need more compute, they scale the compute. And overall, that results in also this kind of agility that allows you to run experiments very, very cheaply. If you can run an experiment, say, with Amazon EMR against your data on S3, you stand up a set of clusters, run your experiment. If it's successful, that's great. You can then easily move it into production. If not, then there's no harm. You just shut down your cluster, that's it. Very minimum cost, and you just take your learnings and run the next experiment. And another thing, we talk about the data warehouse being very rigid in terms of the schema. It allows you to define the schema on read. So that means that you store all your data, and then you can basically ask all the questions you want and then define your schema at that point. And I think this thing is not working anymore. And this is the type of architecture that many of our customers are building today on AWS. We provide a very broad, secure, scalable, and cost-effective portfolio of services to allow you to build a data lake architecture on AWS. And you can look at the screen. You'll find customers from the hottest startups, like Airbnb or Netflix. Well, Netflix is no longer a startup, but I guess you get the point. To also very traditional companies, or companies in very traditional industries. Some of the examples we have today, and Carlos is going to talk a lot more about those, are FINRA and NASDAQ, who play on a very regulated industries, very traditional industries, and they are deploying data lakes on AWS. In addition, we also have a very broad partner ecosystem. This session, as you know, is part of the Global Partner Summit, so you will hear me and maybe Carlos too make a lot of statements around our partners because they are really helping our customers successfully deploy data lakes on AWS. And they do that consulting partners, they do that through best practices and through methodologies, creating quick starts or CloudFormation templates to accelerate the development. And we also have technology partners that have built integrations into AWS so that you can analyze the data with the tools of your choice. And just out of curiosity, how many partners do we have in the room? If you can raise your hand, just to get a sense. Okay, so we have a good number of partners. Yeah. Okay, so now let me take a look into some of these key components of or characteristics of a data lake architecture. The first one, obviously, at the core of the data lake, you have the storage, which kind of constitutes the fabric of your data lake. And the large majority of our customers use Amazon S3 as kind of the storage layer for their data lakes. With S3, customers can store the data in the format that they want. We offer support for the most popular formats, CSV, ORC, Avro, Parquet. And the nice thing about this is that Amazon S3 provides very high durability, availability, and scalability. A lot of the partners here have built integrations to access, connect, either ingest data into S3 or access it or analyze it. Now, of course, the data lake fits on data. So the first step to building a data lake on AWS is to move all the data into the cloud. Now, AWS provides a range of options to make transferring the data to the cloud as fast and as easy as possible. We have tools such as AWS Direct Connect, which allows you to establish a dedicated network connection between your own data center and AWS. Now, for very large volumes of data, we provide AWS Snowball and Snow Mobile, which are appliances that allow you to store all the data there and then ship it to AWS. And you can move petabytes or even exabytes of data. Increasingly, though, I mean, once your database is up there, you have to continuously collect the data and continue to feed the data lake. So one of the very popular tools that the customers use is Amazon Kinesis, which allows you to stream the data into Amazon S3 and even do some sort of analysis in real time if you need to do that. And once the data lands on S3, customers have a very broad set of analytic and machine learning tools to run virtually any type of analytics on their data. As I mentioned before, they can use things like Amazon Athena to run interactive queries directly against the data on S3. And you can just use a standard SQL, and you pay for each query that you run. They can also code very sophisticated applications and run them on big data frameworks such as Hadoop or Apache Spark through Amazon EMR. They can develop, test, and deploy machine learning models using SageMaker. They can analyze data directly from their data warehouse on Amazon Redshift using Redshift Spectrum. They can visualize the data with QuickSight, and so on and so forth. All of this without moving the data. And again, similarly, we have a very broad set of partners that have built tools and integrations so that you can analyze the data on S3. Some of those, Tableau, Looker, MicroStrategy, etc. Now, I wanted to pause a little bit and show you an example that I thought was very, very interesting. We always hear about the big companies that are making a lot of money by leveraging technology. So I like this example because it's a little bit different. We Robotics is an organization that actually uses drones to help in disaster relief situations, in even search and rescue efforts, and even potentially provide emergency communications through aerial hotspots using the drones. Now, one of the key challenges that they have is they go to very isolated regions. In this case, they went to a zone in Peru that is part of the Amazonian rainforest. And they were running kind of a drill, a simulation, to see how they could coordinate different teams of drone pilots to do mapping, basically 2D mapping or 3D mapping that analyzes the vegetation, the water, et cetera. And again, all of this is for disaster relief and search and rescue operations. But how can they coordinate diverse and distributed teams without communications? So what they did is they actually used Amazon AWS Snow Mobile Edge, which is similar to Snow Mobile, but also has compute capacity. So they can actually do some pre-processing of the data right there. And they can do it there, even if they don't have connectivity directly to the cloud. So what they did is this device helps them do the analysis that they need on the field, but it also has a great advantage that once the exercise is over, they can take back that device and load all the data into the cloud to do further analysis and take actions and improve their processes. So I like that example because it shows you kind of the entire process, right? How you collect the data, even in very extreme situations like this, you can upload it to the cloud, and then you can make it accessible for analytics by very different groups. Now, the breadth and depth of analytic options is important, but we also know that security is, or the way we call it here at Amazon, priority 0 for us and for our customers. So on this front, AWS has been architected to be one of the most flexible and secure cloud computing environments available today. And one of the nice things is that all the customers inherit all of the best practices and all the methodologies that have been included on AWS to support our most strict customers, or the customers that manage the most sensitive data. So in addition to our services around identification, authentication, encryption, and compliance, we have a lot of partners that have made also very interesting solutions around security in order, again, to monitor, to audit your environment. And to round this up, AWS supports a very broad set of compliance programs as well. Here's just an example of all the different regulatory agencies that we've worked. So now let's talk about scalability. So with a data lake architecture on AWS, customers can, as I said before, effectively decouple the compute from the storage. And again, this is a very fundamental shift from traditional architectures. So that is a key for the scalability. With the Amazon S3, we have customers that have petabytes, exabytes of data on their data lake, and then they have many different sets of clusters running analytics on top of that data. And that not only provides a scale, but also provides them with the ability to reduce the cost. And all of this is while knowing that their data is stored in a layer that delivers 11 nines of durability. Now, I'm sure you have heard this many, many times, 11 nines of durability. So I always like to put it in real terms, so what that means. So for example, if you store 10 million objects on Amazon S3, you can, on average, expect to incur a loss of a single object every 10,000 years. That's what really means. So you can rest assured your data is fine. Cost. Cost is also important. So with the traditional approach, you simply size, or rather oversize your infrastructure for maximum capacity. We have examples like FINRA that triples the capacity, right? Any single day. Because in the stock market, you may have one day a lot of transactions, and the next day the market is fine. So that means you can basically adjust your capacity to the demand without incurring all the costs for the entire year. And now this works. Another part that we don't always talk about is all the hidden costs of your data center, right? Usually, I mean, it's not only the capacity that you have, but it's the cooling, the electricity, the real estate, the networking costs, all the overhead costs that you can incur with a traditional data center. But of course, a data lake is not only about storing data. Organizations need to be able to discover and catalog their data, making it easily consumable for analytics. So on that front, AWS Glue can automatically crawl your entire data lake and construct a single view across all these data assets. And again, on this front, we have partners that provide and even extend or complement this data catalog. Some examples include Colibra, Zaloni, that can help you with cataloging all the data on your data lake. Now, today, we announced Aws Lake Formation. And what that really means is this new service, it will help customers and partners automate many of these aspects to build a data lake. So I won't go into too much detail about this because there's a specific session where they will show all the details. The session is today at 7 p.m. at Delfino. That's at the Venetian. And you can also look at that link where you will learn more details. But in general, at the very high level, the lake formation, what allows you is basically three basic components. One is data ingestion. It will help you collect all your data and put it into your S3 buckets. It will, the second thing is it will scan all your data and create a comprehensive data catalog around it. And then once you created that data catalog, you can set central policies around all your data, who can access that data, who cannot access what data. And that, when I say central, that means that no longer you have to specify policies for each and individual service that will access that data, like Redshift, Athena, EMR, et cetera. So once you do that, what we are really enabling is self-service analytics, because then what happens is you can have different data sets and make them available through different groups within the organization based on their permissions or based on what data they could or should not access. And again, to learn more, please don't miss the session today at 7 p.m. at the Venetian. Okay. And I'm missing a slide here, but that's OK. So another aspect, we talk about data catalogs, we talk about analytics. So another key aspect of a data lake is data governance. And this year was very special for many of us because I think it's not working. What happened is, you probably saw all the new regulations. GDPR came into effect. We also have the California Consumer Privacy Act, the CCPA. And all of these are raising basically concerns that the public already had, right? Like, who is using my data? Who has the right to use my data? So organizations, for organizations, it's more important than ever to be able to ask and answer those questions. What data am I collecting? Where is it stored? Do I have consent to use that data? And what type of consent? Because having the data and having permission to use it in one way doesn't mean that I can use it in a different way. So that's why we, this year, as part of the Big Data Competency, we launched a new initiative around data governance. And that's actually a new category within our Big Data Competency. What we are looking at is basically answer many of these questions around data governance. And the first step is actually introducing a new solution that we are calling the de-identified data lake. What that means is we are attacking the problem at the root. One of the big aspects of privacy is personally identifiable information, also known as PII. And what we are doing is we created a solution that allows you to basically de-identify all the data, strip all the PII from your data before it even lands in your data lake. But the key here is that all the valuable insights from the data are still there. The difference is you are no longer able to match that data with a specific individual. And we have different components on this architecture. As an example, the first step is the Etl process. In the Etl process, we scan the data. We look for PII. And then when there's PII, we have a masking stage where we mask all that data. What we are basically doing is tokenizing the data. and then we store it into the data lake and make it available for analytics. And then we have another stage there that it's kind of a hitch process that allows to match de-identified data for cases where you actually need the identity of a person. Say everyone has used ADP, for example. You may need to direct the paychecks or shipping, addresses, etc. And I'm happy to talk more about this, and I'll be available after if you have questions. So getting ready to the really interesting stuff. So far, I've talked a lot about data lakes. Why is this? Or what does all this has to do with machine learning? Well, the reality is we found that a lot of the work spent to get to machine learning insights is just collecting, preparing, and managing the data. And the data lake will help you set a very solid foundation so that then you can actually get more value from the data with things such as machine learning. So with that, I will leave it to you, Carlos.
Very well, thank you, Jorge. Yes, so now we come to the second part of the presentation today. We're going to be talking more about machine learning, inferential data science, as I like to call it, which is based, the ability to do inferences is predicated on your ability to collect and move data in your data lake. So before we get into the value generation piece, I'd like to share with you some insights about what our pioneering customers have been telling us and the ones with whom we have collaborated in order to develop these new services, many of which you have seen announced today. But a key aspect here is that the data are messy. Data sometimes are missing, sometimes they're sparse, inconsistent, denormalized. You may have multiple sources of data that you need to combine in order to drive value. And this makes data preparation a particularly arduous and manual task. So much so that many data scientists actually find themselves spending 80% of the time preparing data. And I can tell you also that many data scientists actually resign because they're not given the right tools to drive value. I can tell you specific examples of people who have been offered deep six-figure deals, moved to Dubai with the promise of making very big things, and then a couple of months later, they're back in London, frustrated because they feel that their career is not moving fast enough. This is a reality today. It is really a critical problem that many companies face, and many companies are actually addressing by putting together data ops teams for whom the data lake becomes absolutely foundational. Now, looking at machine learning projects without the proper tooling, if you look at the picture in front of the pioneers in machine learning adoption a couple of years ago, they were looking at cycles of between 6 and 18 months from the moment a model is ideated to the moment that it is actually commissioned to provide inferences online. And the reality is that this part of preparing data requires very heavy lifting, particularly if you're trying to do deep learning. The amounts of data that are required in order to do deep learning basically necessitate extremely large clusters of data. And doing that on premise is particularly difficult, extremely arduous. It can take weeks, if not months, even if you have the hardware, to get the right configuration just to start a training job. And you need many, many, many training jobs until you finally become comfortable with a model being of the sufficient precision in order to go and move it in production. Now, depending on the data velocity, models have to be retrained more or less often. For instance, if you're doing facial recognition, well, we age, but we age slowly. So I'm sure that if they do a model for my face today, I hope it will be recognizing me a year from now. Now, if you are in ad tech, actually, the data velocity is absolutely tremendous. You have to retrain models practically daily. That was impossible to do under on-premise architectures with the tooling that was available at the time, a couple of years ago, as I mentioned. So now with the advent of the data lakes, we are beginning to decouple the data operations from the data science. So looking back again, if you look at the pioneers in this space, a couple of months ago, they put together full stack teams where you had data scientists, data engineers, and DevOps specialists that collaborated in order to do all of this heavy lifting that I just referred to. The data lakes, the first thing that they do is they actually allow this decoupling. The data ops can concentrate on the data engineering, and then they serve the data to the data science teams, where the data scientists now have less to do with regard to the data preparation. And that brings efficiencies because then experimentation can proceed significantly faster. In this regard, having a data catalog becomes also a foundational capability for a company because it allows the data scientists to be more self-sufficient, and then it also enables the emergence of this new position, the citizen data scientist, that actually does their own data science with the tools that are provided. Now, looking at what AWS has been offering, I remind you that exactly 1 year ago, we announced the SageMaker, and that has become an absolutely foundational product for many organizations. This is what pre:/:invent. This is the previous line of technologies, and if you watched the keynote this morning, you saw that there was a torrent, an absolute fantastic amount of new technology that has been made available. We think about our stack in these three different layers. The bottom layer would be infrastructure and frameworks. This is normally something that very expert people would use directly. For instance, those that can program FPGAs may want to actually go down into the infrastructure and touch it. Or those that feel comfortable preparing their own images in order to do model training. That is still an area where perhaps there's a few tens of thousands of people in the world who can do that. There's not a lot of them. The fact is, it is very difficult to do. There's not a lot of people doing it. The next layer up is the layer for the data scientists with SageMaker that we have extended significantly with the announcements today. The announcements today extend now the ability for data scientists to do data annotation, which is one of those tasks that take so much time and require so much effort. We're also actually providing more and more optimization tools. We had already hyperparameter tuning. Now we have a compiler in order to make the models more efficient for inference. We will continue to work a lot on this layer to make the data scientists, to have them become more capable of experimenting and then be able to utilize the data lake much faster and be able to experiment significantly more. And then up at the top, you have the APIs where we serve our neural networks through APIs. And this is for developers. So developers in the world, there's probably about 20 to 25 million. And these developers do not need to learn anything about machine learning or artificial intelligence in order to take advantage of these neural networks. And as you saw today, we increased the modules available, adding forecasting and personalization. These are actually, if you will, the low-hanging fruit. This is what we see the most use of machine learning today. And the fact that it is now available through an API is going to accelerate projects significantly more. The fact that we have these services does not mean that the data preparation work disappears. Quite on the contrary. You still need to be able to pipeline the data, to prepare, to curate it, depending on the specific use case. We also have been, last week we had a lot of enhancements also to the existing products. Is the clicker getting fixed, Jeffrey? Okay. For instance, we added 7 new languages to translate. We have also announced a medical terminology library for Comprehend. And we're going to keep making our neural networks more accessible and more feature-rich in order to address that constituency of developers who want to access, thank you. It seems to be working. Who want to access those neural networks. Now, I'd like to spend a couple of minutes talking about the data science practitioners and data scientists. It's a little difficult to estimate how many people there are in the world. A rough number is approximately 1 million that would be in this area. And I realize that many of those would be business analysts or business intelligence analysts that are retraining themselves for machine learning. Very, very clear that this group of people is going to grow very, very rapidly. And when we see how machine learning is being adopted in corporations, these teams tend to be embedded in the line of business. And they have, the numbers are growing significantly. Those companies that actually are driving the most value to their shareholders tend to have a very high rate of experimentation with data. And this is what we see with SageMaker. Is the fact that data science, after all, is a science. It is not a project with an ROI where you can basically start to calculate exactly how much it is going to cost. You cannot be agile necessarily with it, right? Because in order to find out if you can drive insights from the data, there is a need to experiment. This is what we're trying to tackle with SageMaker, is to reduce drastically the cost of the experimentation. And we make it very easy for data scientists to build, train, and deploy models. And when we talk about deployment, bear in mind that with machine learning, you actually do a lot of experimentation and testing in production before you actually decide to deploy a model or apply it to a wide variety of transactional situations. A/B testing is common, ABC testing, DE testing actually. And the majority of solutions tend to be ensembles where you actually have a combination of models. And the models always operate at their best right fresh off the oven, so to speak. And then after a while, they degrade. The models have to be measured for performance, for precision, and then they have to be retrained periodically. What we are able to do here is for the data scientists to perform all of these tasks without having to have support from data engineers or from DevOps specialists. And then they can move significantly faster to interact with the developers, make the models available through APIs, and then start to test them and move them progressively into production. This is what we see as the foundational aspect to have this virtuous flywheel, where with more data, people can make better decisions. These decisions actually allow product managers or service managers to ideate new products and new solutions, drive more users, and then an increasing amount of data keeps feeding on itself because then there are more decisions that can be taken. It is really an exciting area because we are beginning to see companies starting to take these models and productizing them. And data products actually are a very exciting new field that open a lot of opportunities that can be far beyond the scope of the original company. For instance, we have a very dear customer in Norway. It is a cooperative with dairy farms that came up with models to predict milk production with fat content and even to have predictors on the nutritional requirements of individual cows in their cooperatives. Well, the model was so successful that they actually spun that off as a separate company. And that company now is actually a software company. It's no longer anything to do with agriculture. And now they sell those inferences to farmers around the world. So this is a very exciting field because you can actually do this experimentation, you can move into production, trial it, and then you can actually start a new business, and you do this in a matter of months. It is really quite amazing. And this new company has been capitalized with 200 million kroner, which is approximately $30-odd million, and they are now selling these data products internationally. It's quite amazing. I think it's very exciting about how quickly you can put new business models together with data. Now, in order to explain this process, Jorge and I have designed this poster. We have some samples over here. Some of them want to take it. And what we want with this poster, which is quite detailed, okay? We came up with this simplification so you can see what it does. It allows you to describe and have a conversation in your company or with your customers about how you build value with data, so that you can talk about the data sources. When you talk about with your customers and you tell them, you ask the questions, what is your corporate data like? They're very likely going to start thinking about SQL Server, Oracle, relational data, and so on. And it's very important that you really get all the way to the bottom, semi-structured and structured data. Dark data is typically down there, unstructured. Voice conversations, videos, chats, emails. And if you really want to know the pulse of your business or your customer's business, that's where it lies. The structured data there on the top is actually transactional. It basically tells you what happened, and most of the time is what happened successfully. But if somebody is unhappy about the product, about the feature, if you have support issues, unhappiness, churn, the data are actually down there on the structured side. So that is the beginning of value creation, is just to drive awareness about the fact that there's a lot of data lying around in different silos, in different components, in different systems that can be awakened and start to generate value for the company. So the creation of a data lake starts with the pipelining and having robust processes that move data efficiently and quickly to the data lake where you can land it. And then very importantly, you want to enrich it. Third-party sources of data are becoming extremely important in data lake projects. So this is, as you can imagine, meteorological data, demographic data. And we're starting to see many governments actually pushing their different ministries, departments, and agencies to make data owned by the government public. For instance, we have a partner in the United Kingdom that took crime data, combined it with street-level view data. They analyzed how sturdy houses were. They looked at the frames, whether windows had bars, and so on. And then they had a predictor for the likelihood of being burgled. And that is actually used to adjust premiums, property premiums in houses. So it is really quite inventive what you can do with these third-party sources of data. We have an open data initiative, and we have some 85, 90 public data sets that I invite you to examine, that you can use for your experimentation or to enrich also your own data. So then once you have the data landed in the data lake, then you can actually have a single source of truth that you can either use for descriptive data science or business intelligence, or make it available to the data scientists so that they can do their experimentation, and then leveraging SageMaker, that experimentation can result easily in an endpoint that can be tested, and you can also connect it with IoT Greengrass and then have the inference model moved to the edge, to an edge device. And this is the full picture that we invite you to help yourself with the poster here, and then use this to have a conversation about how you can build value in your companies. A couple of examples of some of our pioneering customers in Intuit. Nungho actually has a very nice video that is hosted in our website. It's, I think, about 4 or 5 minutes, and she actually goes through some of the pain points that she had with her team when they were doing their own tooling. And they had to create their clusters, move the data, prepare the data, and so on. And she talks about how the experience changed completely once they built a data lake on S3 and they started to use SageMaker. So they've gone from this process that used to take at least 6 months down to about a week. in order to, from the moment they ideate a model until they can actually move it to production. Another good example of this is Airbnb. This would be a good example of a customer that can work, that they have the practitioners and the researchers, and they actually do a lot of their own stuff with the infrastructure and the frameworks directly. For instance, they have taken Jupyter and they have developed their own version. It's called Redspot, and I believe that they have very recently made it open source. They use our P3 instances in order to accelerate the model development. And it's really absolutely remarkable how far they have gone in terms of personalizing the experience of the users in a way that the hotel chains really struggle to keep up with. Another good example is FINRA. Now, this is a non-profit. Okay, so it's a non-profit that is missioned by the U.S. Government, but it is separate. It does not belong to the SEC, although it does report to the SEC. And they actually survey 99% of the stock trades and 70% of the options trades in the United States daily. 75 billion events are ingested and monitored. And they apply machine learning, among other activity that they look at is insider trading. And with the results of their work, then they pass that to the investigative units at the SEC. We have another example in Toyota, which resonates a little bit with the story this morning from Formula One. Now, this is not the Formula One side. This is about autonomous driving. It's kind of interesting to remark that a teenager, maybe they drive 50 or 100 kilometers, and then they go and they take a driving test and they pass. Machine learning models, they take a few million kilometers, maybe billions even, before we can be comfortable that they learn enough. This is one, by the way, one of the interesting asides of machine learning, that it takes, we don't know why we can learn so quickly, and yet the mathematical techniques that we use to simulate or to create inferences, they take us a lot more effort for them to converge. Another good example is NASDAQ. Now here we're talking about 5 billion rows ingested every day into, that's just the data warehouse, by the way. That's just the data warehouse. In addition to that, they are extremely heavy users of EMR to process historical data. NASDAQ is one of these organizations where the average to peak ratio is about 3x. So in days that are extremely busy, they have to scale almost, obviously, without warning. Okay? That is not something that you can plan for. Again, almost impossible to do if you are doing this on-premise. Another example, and this speaks to the value of having not only robust pipelines, but actually the ability to move the data quickly in order to generate value. It used to be that the National Hurricane Center, which is part of NAMA, would issue warnings every 3 to 4 hours, update warnings every 3 to 4 hours regarding the movement of hurricanes. And by building a data lake and piping the satellite imagery, they can actually update the position of the eye of the hurricanes now every 15 minutes. And this much faster way of handling the data obviously has a direct impact in terms of saving lives and potentially also saving, well, in some cases, or moving first responders to areas and, where they can at least assess or deal with property damage a lot faster. All right, so I want to give you a couple of takeaways, and I'm going to give you one that is particularly near and dear to my heart. If you work with CFOs, okay, I would like you to deliver the message that data is not a cost. Data have to be looked at as an asset, and in the same way that they have a fiduciary duty to their shareholders to maximize their return on assets, data have to be considered one of those assets whose value they are accountable and responsible for generating. And this is not a sales pitch. This is a fact. This is a fact. The majority of the stock market value today is actually being generated from intangible assets. And we don't really have a way to account for that at the moment because there is a regulation, it's called IAS 38 in the United States, that actually disallows the capitalization of data. Be that as it may, on a non-GAAP basis, CFOs and CFO organizations should be able to quantify the value of the data and the data products, particularly for those companies that are looking at increasing shareholder value through data, inferential data science in particular. So the data lake is one of those foundational capabilities. Just like knowing which algorithms to use, data lakes actually become foundational to the creation of value for corporations. We covered how you can deal with objections about compliance and risk regarding the use of PII, and you will see more and more solutions to build governance, to have security and anti-tampering, tokenization, and so on, as we build out our data lake formation. Machine learning practitioners can now operate autonomously. They don't have to be coupled with data engineers and DevOps specialists, and actually they can do much more experimentation and really do the science bit of data science. And then for those developers that want to avail themselves of neural networks, we provide them through APIs and with basically zero complications, as we provide them as a managed service. So here we have a few links that obviously this presentation will be available very soon, hopefully within a few days, that you can use in order to dig a little deeper. And of course, Jorge and I are still available for a few minutes to take your questions.
Awesome. And just a reminder, we have a set of posters here that if you want to grab one, feel free. Just put them
please.
here.
Okay, so the question that we have is, sorry, what country is it? Australia. Okay, where there is a regulation where the systems of record are cannot be on the cloud. I am not familiar with that law or that regulation, but obviously that is a regulation. So it's a little. Yeah, I mean, what we can do is maybe put you in contact with our team, because we are working with the authorities on all of and Australia is one of the countries at the forefront of machine learning adoption, okay? And then we can advise you on who we're speaking with in order to find out why that is a problem and how we can address it.
Yeah, and if you can give me your info once we are done. One of my colleagues that leads the competency from the technical perspective, he worked in Australia for a long time, and he's very familiar with those things, so I might be able to get you a better answer. Yeah.
Okay, we have time for one more question. Yeah.
There is this problem with the PII, and then we also have this objective of breaking silos. But if you have a client or a customer that has this information and you have different systems, what is your recommendation for companies or businesses that are trying to break the silos, but at the same time they cannot really match registries from different silos, put it that way? Because they don't have the PII, so they cannot match the data.
Yeah, so actually that's a common problem that we have heard, and the first kind of part of the answer is the identified data lake, because that when you do that, we have built in a mechanism that allows you to basically strip all the PII, but then we have a third-party tool that it's kind of an independent process where they are actually able to not re-identify the data, but match it with their own records. So I can explain to you more offline how the process works at the high level. But basically, the idea of the identified data lake is basically that it allows the companies to still leverage the data because all the insights are there, like the preferences, the colors, etc., but none of the PII. So that means that if there's a data breach, the data for the hackers is mostly useless. And also the companies don't have that risk or that liability of managing PII because if they are out of compliance, then they have to pay big fines, right? So what you do is you have another entity here that can also go through the same process of tokenizing the data, and there's a huge process that matches the data. I can explain more offline on how that works.
All right. Now we need to bring this session to a close. Jorge and I will stay here for a few more minutes. Thank you very much for your attention.
Thank you very much.